Imagine this. You're at a party when the conversation hits a lull. So, in accordance with social mores and ancient sitcom tropes, it's now the time for you to bring up the weather. And so you say, glass of wine in hand, did you know that Jupiter's Great Red Spot is a storm wider than the entire Earth, and it's been raging for at least 350 years? Of course, now everyone is so happily surprised that you decided not to talk about the weather on our planet that they demand you shower them with even more examples of extreme weather out there. So here are 7 other examples of awesome solar system storms that you can use. Jupiter's Great Red Spot might be the most famous cyclone in the solar system, but in my opinion, it can't hold a candle to Saturn's hexagon. Scientists use the term cyclones to refer to any large mass of spinning air with a low pressure center. You know, the whole eye of the storm thing. But depending on exactly where they happen, you may hear them go by different names, like hurricane or typhoon. Earth's largest on record was Typhoon Tip, which appeared in the Pacific Ocean back in 1979. And at its widest, it stretched an amazing 2,200 kilometers. That's about half the width of the continental US. But this storm is absolutely dwarfed by the hexagonal cyclone system encircling Saturn's North Pole, which is roughly 30,000 kilometers across. That's over twice the diameter of our entire planet. And at the center of this hexagon is one storm roughly the size of Typhoon Tip, surrounded by multiple smaller vortices embedded within the larger hexagonal shape. This monster storm was first discovered back in the 1980s, as the Voyager 1 spacecraft did a quick flyby, but our best view came courtesy of the Cassini mission, which actually orbited the planet for more than a decade. So thanks to all that data, scientists have been able to reproduce geometric shapes like it in the laboratory to figure out exactly what atmospheric conditions need to come together to make a polygon as opposed to like a big circle. And in addition to that, they're also still working to understand a completely different quirk this storm has. It's changing color. In 2013, the storm system was dominated by these like bluish green hues. But by 2017, when Saturn's summer solstice arrived, the hexagon had shifted to a mostly golden haze, while the central storm, or eye, remained blue. Researchers suspect that this evolving color may have been caused by an increase in solar radiation, which would smack into the molecules of methane and break them apart and force a bunch of chemical reactions to form more complex hydrocarbon particles. So, in other words, Saturn's version of smog. But speaking of methane in the Saturnian system, there's a neighboring world with a different kind of storm that you can bring up at this otherwise dull party. Titan is Saturn's largest moon, and it's really famous for its thick golden green atmosphere, which, much like the Earth's, is mostly made up of nitrogen gas. But very much unlike the Earth, this moon is home to dust storms made of methane. See, Titan is about 10 times as far away as we are from the sun, so its temperatures are frigid. It's so cold out there that methane, which is normally a gas on Earth, can be in a liquid or even solid state of matter. And in fact, instead of a water cycle, Titan essentially has a methane cycle. Methane and other hydrocarbons pool into lakes and oceans, and they evaporate and they form clouds, and they rain or snow back down onto the surface. And around Titan's equator, planetary scientists have spotted what appear to be vast dune fields made of tiny solid particles of methane. But seasonal changes can cause the winds to pick up and the methane storms to kick into gear. Back in 2009, scientists observed bright patches of what appeared to be methane dust getting swept up out of the dune fields and into the atmosphere. In other words, it was a methane sandstorm. Hey Google, play Sandstorm by Darude. Titan is now only the 3rd body in our solar system known to have dust storms, after Earth and Mars. But knowing that isn't just a fun fact, although it is a fun fact. NASA has an upcoming mission called Dragonfly that is sending a fancy helicopter to Titan. And to make sure that mission runs as smoothly as possible, scientists need to understand what hazards and conditions those methane storms might pose. But speaking of Mars, the red planet is famous for its planet-wide dust storms. Rust-colored grains can get kicked kilometers into the thin Martian air, and all that dust can darken the skies for months and spell doom for a solar-powered robot. But researchers suspect there may be another kind of storm that rovers and landers may wish to avoid. Snowstorms. Yes, good old-fashioned snow. Mars is a much drier world than Earth. Most of the water we know about is locked up in the polar caps, alongside a bunch of frozen CO2. But there is some water in its atmosphere as well. In fact, thin wisps of water ice clouds can often be seen in satellite imagery. And during the day, these water ice clouds hang tens of kilometers above the surface, absorbing heat from the sun and staying relatively warm, at least warm by Mars' standards. But scientists have created climate models that show that nighttime conditions in these clouds might be very different. When facing away from the sun, atmospheric temperatures plummet, and so does the temperature of the water in those clouds. So the now much colder air and water ice particles end up falling rapidly towards the ground, while warmer columns of air rush upwards. You get a bunch of convection happening inside these clouds, and it may be enough to create microbursts, extremely intense but localized bursts of snow. Those microbursts can then distribute water throughout the different layers of Mars' atmosphere and cause havoc for any spacecraft unlucky enough to be trying to land during the storm. But if snow on Mars isn't enough to continue impressing your fellow partygoers, maybe some other form of strange precipitation will. We mostly picture rain and hail happening on planets with solid surfaces, but guess what? Precipitation happens on Jupiter. In fact, it's incredibly common, but it's not necessarily the familiar water like rain, snow, hail, or sleet that we're used to. Jupiter is mostly made up of hydrogen and helium, but only mostly. There's plenty of other compounds swirling around in Jupiter's atmosphere. And that includes water vapor like we have raining/snowing down on Earth and Mars, but thanks to data provided by the Juno mission, scientists have discovered Jovian weather events that are partially caused by ammonia. For example, Jupiter experiences a type of electrical discharge called shallow lightning. It's called shallow because it occurs very high up in the atmosphere, which, when you're looking at it from above, like all of our telescopes do, translates into being at a shallow depth. And way up there, it's too cold for just plain water clouds to form. So the fact that astronomers were seeing lightning at that altitude was a bit of a mystery until they figured out that ammonia was also in the mix, because adding ammonia keeps the water liquid at lower temperatures. And so now that we've got clouds, we also need a way to make the lightning. Specifically, we need a buildup of opposite electrical charges that appear far enough apart from one another. And one way to create this separation is through the movement of precipitation like hailstones. But because Jupiter's got these like ammonia water clouds instead of just plain H2O, its precipitation is a little special. Astronomers call them mushballs. Yes, that is the technical term. They form and grow similar to hailstones in Earth's atmosphere, with concentric layers of water, ammonia, slush, and ice building up layer after layer as the balls rise and fall inside the cloud. Eventually, the mushballs become too heavy for the cloud to hold up to a kilogram each, and they fall deeper into Jupiter's atmosphere, where eventually they finally reach warmer temperatures and evaporate back up again. So be sure to warn your party guests that should they ever somehow find themselves plunging into Jupiter's atmosphere, instead of encountering happy little raindrops, they'll need to prepare to face fierce lightning and giant hailstones. And while we're talking about Jupiter, why not mention its spectacular auroras, which put Earth's northern and southern lights to shame. Auroras form when charged particles in the form of plasma interact with the body's magnetic field and atmosphere. And so on Earth, we're familiar with that plasma being delivered by solar wind and solar storms, causing those auroras to come and go. But unlike Earth, Jupiter has massive, apparently permanent auroras at each pole, and researchers are trying to better understand the phenomenon as well as the transient storms that occur within them. In 2021, they were able to use data from the Juno spacecraft to study a rare but spectacular kind of aurora known as dawn storms, which appear on the line between night and day. Scientists have been aware of dawn storms since the 1990s, but before Juno came along flying directly over Jupiter's poles, they couldn't get a full view of how they formed. Now we know that these storms begin on the night side of Jupiter, but as they rotate to face the sun, they ramp up activity and grow even more luminous, outshining the typical Jovian aurora by tenfold, which means dawn auroras can pump out hundreds to thousands of gigawatts of power. For comparison, the entire US used a little under 500 gigawatts in 2023. It's just too bad human eyes can't see the type of light that these storms are giving off. They're an ultraviolet phenomenon. But luckily, we do have spacecrafts and telescopes that can translate this spectacular sight for us. Another sight you wouldn't want to miss? Mercury's magnetic tornadoes. Mercury might be like the last place that you'd expect to see storms, because well, you can't have a storm without an atmosphere, right? And since Mercury is the only planet in our solar system without one, right? Well, it turns out that Mercury actually doesn't have no atmosphere. It's just very, very, very thin. And it's so thin, you might just hear it referred to as an exosphere, which is the word astronomers use to refer to the moon's atmosphere too. Because it orbits so close to the sun, that's why it's so thin. Our star's radiation is just too intense over there, even with Mercury's protective magnetic field. Those solar particles slam into Mercury's atmosphere and strip it away into the greater void of space. But shouldn't that mean that Mercury really should have no atmosphere after 4.5 billion years of this? Like, what could be replacing it? Well, in 2008, the Messenger spacecraft was doing the rounds and spotted what astronomers called magnetic tornadoes. These weren't tornadoes like you'd find in Kansas, though. Mercury's atmosphere is definitely too thin for that. Instead, the term describes twisted up vortices of magnetic field lines. See, wherever you have charged particles moving around, it can create a magnetic field. Mercury's weak magnetic field is only about 1% the strength of Earth's, but it's probably generated by a similar process to Earth's, liquid iron ions turning around in the planet's core. But charged particles streaming from the sun can also generate magnetic fields, and when those magnetic fields connect with Mercury's magnetic fields, they can create twisted bundles of field lines. And because of all that twisting, you get holes in the planet's shield, little magnetic tunnels that open up Mercury's surface to get pelted directly by the sun's radiation. That radiation can then blast atoms off the planet's surface, turning them into that super thin exosphere. So the sun is both responsible for stripping away Mercury's atmosphere, and then through magnetic tornadoes, replenishing it over and over and over again. Which I'm sure you could connect to some ancient Greek myth to make those party guests think you're even more of a nerd. And speaking of mythology though, we're gonna end with Ouroboros, the snake that eats its own tail. Because we're not just wrapping back around to Saturn, we're covering a storm that grew so large it ate itself. Down here on Earth, storms like hurricanes quickly dissipate after they run aground. But if you're on a planet with no land or topographical features to slow down a gas giant's tempest, they can last for centuries, like Jupiter's Great Red Spot, or grow so large they wrap around the entire planet. In December of 2010, Cassini scientists spotted a monstrous storm forming in Saturn's northern hemisphere. And within months, it had stretched out horizontally to a length of roughly 300,000 kilometers. That's almost like 8 times the circumference of Earth. And for the latitude it formed at, that was enough for the leading edge of the storm to smack right back into its own trailing edge. And finally, having become like a weather version of Ouroboros, it just sputtered out. This was the first example ever recorded of a storm eating itself, which personally I think is a way cooler event than some like centuries-old red dot on Jupiter. But for all you Great Red Spot fans out there, we can both agree they're both way cooler than whatever's happening outside the window of this like lame party. Luckily for everyone, you're there to talk about the weather. But jokes aside, this party isn't just an opportunity to gush about space storms. It's also a chance to show off an awesome pin you just bought, because we've taken Saturn's hexagonal cyclone, shrunk it down so you can fit it in your hand, and turned it into metal, as opposed to the mostly hydrogen and helium that comes with being a gas giant cyclone. You can pick up one of these limited edition pins by heading over to dftba.com/scishow. Thanks for watching.